Good morning, everyone. I am Madhuri Murik, working as an assistant professor in Electronics and Computer Engineering Department, Sharad Institute of Technology, College of Engineering. Today, we are going to see the electromagnetic waves. So, for communication engineering, the radio waves as well as the electromagnetic waves are very important one. They plays very important role while they are exchanging or the traveling from in a free space. So whenever there is a communication engineering comes, the spectrum band, that is nothing but the frequency band, comes into the picture, and there are various frequencies are related to the engineering applications comes. So here for the communication engineering, electromagnetic waves are very important one. So let us see what is mean by that electromagnetic waves. So electromagnetic waves is nothing but that there is a magnetic as well as electric field. So a changing magnetic field produces an electric field, and a changing electric field produces a magnetic field. So electric and magnetic fields can produce force on charges. So an accelerating charge produces the electromagnetic waves, that is nothing but the radiations. So whenever we are broadcasting any signal, the radiation is the very important one. So the electromagnetic connection means what? The generation of that the electromagnetic waves. So how the electromagnetic waves are generated? So you know that whenever there is a current carrying conductor is there, and we are applying that the electric field to that the conductor, then the perpendicular circular magnetic fields are generated around that the current carrying conductor. So just like that, a changing magnetic field produces an electric field, and a changing electric field produces a magnetic field. So electric and magnetic field can produce forces on the charges. So according to the Coulomb's law, whenever there are two charges in that the free space, then they are in between that there is a force, and that force is given by that the Coulomb's law. So in an accelerating charge means what? Whenever there is a motion charges, means maybe that is magnetic or electric, so it produces electromagnetic waves, and that is known as the radiation. So both electric and magnetic fields can transport energy. So electric field energy used in electric circuit, for example, released in a lightning form. So we can see the example of the electric field energy, that is nothing but the lightning. So that electrical circuits are releases the lightning, and we can say it is the electric field energy. Then magnetic field carries energy through the transformer. So for example, we know the transformer, step down and step up transformer. So transformer having primary side and secondary side. So in a primary side, we are going to provide the 230 volt, and according to our requirement at the secondary side, we will get the step down or step up voltage. So the one energy means in the electric form energy flow from that the primary section of the transformer. So it will generate the magnetic fields, and that magnetic fields mutually transferred into the secondary coil of the transformer, and that magnetic fields are again converted into the electric field in terms of the step up and step down. So we can say that the transformer is the one of the best example of the magnetic field transport energy. Here the electromagnetic radiation shows, the figure shows that electromagnetic radiation. So interrelated electric and magnetic fields traveling through space, because the free space is the media where the EM waves travel easily. So here that fields are traveling through the free space, that is nothing but the, what is the speed of that EM waves? So we can say that the light speed or the speed of that the EM waves. So all electromagnetic radiation travels at the velocity, or we can say the speed of light, that is nothing but the 3 into 10 raised to 8 meter per second in a vacuum. So this is the cosmic speed limit. So real number of that the speed of the light is comes exactly into it is nothing but the 299792458 meter per second. Okay, so EM wave travels according to the light speed in the free space. So let us see what is waving in EM waves. So what media transports sound waves? So here the sound waves in the vacuum that are traveled through the particles which are available in that the vacuum. So the vibration of that the vacuum molecules will responsible to travel the sound waves into the vacuum. Then what medium transports water waves? So water, in the water that the water surface is, or that the water movement is responsible for that the whatever the EM waves travel through that the water waves. So what medium transports the radio waves? So waves use the free space. So there is no any requirement of that the physical device to travel that the waves into the free space. So free space itself take care to travel that wave from the one point to the another point. So here, a topic of considerable debate in the late 18th and early 90s led to concept of the Lumifer's ether or invisible zelo that was thought to vibrate electromagnetically. Experiment that solved this ether didn't find it. This was quite a surprise. So electromagnetic waves travel through empty space. That is the conclusion from that the experiment. So the wave or the waving in the EM waves, so the radio waves will travel easily from the free space. So let us see some examples of electromagnetic radiation. So as we know that AM and FM radio waves, so here the AM is including the TV signals. So FM audio signals are there, and in AM video signals are there, and combinedly we can send these radiation for that as a TV signals. Then second example is the cell phone communication links. So cell phone communication links are also nothing but the EM waves. Then microwaves, so we can use that microwaves to cook the foods. Then infrared radiation, again the infrared radiation is used to in a special application, so for the proximity detection and other things. Then light, in terms of the light we can use the EM radiation. Then X-rays, which are the very important way in a biomedical engineering. So for the patient we can check whether that the means fault is created in a human body with the help of that the X-rays. Then gamma rays are also used for that the biomedical applications. So here what distinguishes these from one another? So answer is the range of that the frequencies are distinguishes these from one another. So here some uses of electromagnetic waves are highlighted. So in a communication system there is a one-way communication or two-way. So both the sides. So broadcasting is the one-way communication. So from satellite the signal are launched, and at the earth station different receivers are receiving that the signals. And two-way, that the cell phone communication is the two-way communication. Then another example of the EM waves are nothing but the radar, radio ranging and detection. So here the special frequencies or EM waves are used in a defense to find out the targets. Then in a microwaves are used for the cooking. Then in a medical imaging, the X-rays are used or X-rays are used. So in a night mode or night vision, the infrared waves are used. And in astronomy, radio, microwave, IR, visible, UV and gamma EM waves are used. So all that we experience through our eyes is conveyed by electromagnetic radiation. So the electromagnetic spectrum is the one of the important one. So here we are going to relate that frequency, speed and wavelength. So the relationship between frequency, speed and wavelength is nothing but the speed of the light is nothing but the product of frequency and wavelength. So F is the frequency, lambda is the wavelength and C is the speed of the light. So different frequencies of electromagnetic radiation are better suited to different purposes. So just like we have discussed the examples, so we can conclude that the different frequencies of electromagnetic radiations are better suited to the different purposes. So as per the application or as per the requirement of the application, we can choose the different frequencies of electromagnetic radiations. The frequency of radio wave determines its propagation characteristics through various media. So the propagation constant is very important one while the rays are traveling with the different frequencies. So here the frequency allocation is shown. So radio frequencies, that is space is allotted to the hill and sample region from 300 to 600 megahertz. So 300 megahertz has a wavelength of 1 meter. So see here, some part of that the frequency is for the mobile, then mobile satellites and fixed frequencies are there also, and another that is aeronautical radiation. So here that 322 megahertz up to the 355 megahertz, these are used for the mobile and satellite, as well as up to the 399 megahertz. Then afterwards radio aviation satellite, then mobile satellite, then these frequency comes under that the another applications. Then radiologist, so which is nothing but the biomedical applications. These band of frequencies are used, that is ranging from 420 megahertz to the 450. Then for the landlines, only 450 to 460 megahertz frequencies are used. Then land mobiles comes under that. Then for the broadcasting of the TV channels, which are used from 470 megahertz to the 512. Then broadcasting of the TV channels means more than the 21 channels. So remaining are uses 512 megahertz to 608 megahertz. And the radio astronomy used these frequency band. So this comes under that 608 megahertz up to the 614. So this is the international allocation. For that the frequency allocation for different applications. So you can see the number of applications covered under that the 300 to the 600 megahertz. So here, generation of radio waves. If charges oscillate back and forth, get time varying magnetic field too. So note that the magnetic fields are perpendicular to the electric field vector, and therefore there is a generation of radio waves. So see the figure, there is a oscillation of back and forth as well as in with respect to that time varying magnetic field. So here the signal shows that magnetic fields are perpendicular to the electric field. So this green bar shows that the electric field vectors, and this red color rings shows that the magnetic fields. So the relationship between these two, both are they perpendicular to the each other. So how the polarization of radio waves takes place? So here the transmitter antenna is shown. So from which the electric field as well as the magnetic field, they both are the perpendicular, as well as the way of propagation is also perpendicular to the electric and magnetic field. Here the red line shows the electric field. So the vertical and the downwards arrows show the electric field, and these blue lines shows that the magnetic fields, and the red line towards that the way of propagation, that is nothing but the direction of the propagation. So here the electric field, magnetic field and way of propagation all are the perpendicular to the each other, so we can say that it is transverse electromagnetic field. Here, so reception of the radio waves means from the transmitter side the EM waves travel through the free space and reach up to the reception side. So receiving antenna works best when tuned to the wavelength of the signal, because the transmitter side and receiver side the antenna must be designed like that both the antennas should be matched to each other. One is for the transmitter side and another is for the receiving side. So the wavelength of the signal and has a proper polarization, and then only then the max energy is traveled from one point to the another point. So here the electrons in antenna are jiggled by passage of electromagnetic waves. So here the signal comes from that the transmitter side to the reception side. So we have to choose the optimal antenna length in 1/4 wavelength, that is λ/4. So what we have seen from in this lecture, so electromagnetic waves are nothing but the electric and magnetic waves, and they are perpendicular to each other. Also the way of propagation is perpendicular to each. So means electric field, magnetic field and way of propagation, these all three are perpendicular to each other, and they are traveling in that the free space which is having light speed velocity. So we have seen the which medium is used for that the EM waves, as well as we have seen the frequency allocation for that the electromagnetic waves. So there are huge applications of EM waves, and according to that applications the antennas are designed for the EM waves, and there are huge number of applications for the EM waves. So how the EM wave is generated, what is mean by EM wave, how they are travel from that the free space, and how they are related to each other, means frequency, that wavelength and the speed of light, that we have seen in this lecture. So any doubt, then please ask me. Thank you.